Hi everyone, and welcome to the CSRO Future of Meetings talk. My name is Glenn, and as a member of the organising committee for this conference, I wanted to take a moment to acknowledge the traditional owners of the land on which we're meeting. For me, that is the Darug people, and so I'd like to pay my respects to their elders past, present, and emerging. Now, it is my great pleasure to introduce to you all today our next keynote speaker. He's the CEO and co-founder of Pinscreen, a startup that builds cutting-edge AI-driven virtual avatar technologies, Dr. Hao Li. Now, before his time at Pinscreen, Hao was an associate professor at the University of Southern California. He was also the director of the USC's Institute for Creative Technologies, and he has a long history of working in animation, most notably at the industry-leading visual effects studios Weta Digital and Industrial Light and Magic. He's here to talk to us today about his incredible work in the field of realistic virtual avatars, their use in improving human-to-human interaction and even human-to-AI interaction. And I'm sure he will touch a great deal on the impacts that such technologies will have on the future of meetings. After the talk, Hao will be joining us for an open discussion call, which you are all welcome to join, and together we can grill him on more information about these exciting technologies. Please enjoy the talk and join me in welcoming Hao for his presentation. Thank you.
Hi everybody, my name is Hao Li. I'm the CEO and co-founder of Pinscreen, and today I'd like to give a talk on virtual connectivity and avatars in a post-pandemic world. So as you know, I've been working for a long time on the problem of how do we create photoreal virtual humans and how do we make them really accessible to everyone so that we can use them to, for example, improve how we communicate in the future. So, this is sort of like the world we're living in today. It's very dystopian, and as you can see, the social distancing, people have to wear masks. We're trying to avoid each other. A lot of seats are empty when you're thinking about live concerts, live events such as sports matches are all being shut down, which obviously costs the industry a lot of money. And this forces a lot of the physical stores to go online, right? So we're moving toward this digital society, and some of the numbers say that over 30,000 physical stores are going to be closed by the end of this year. And as we're all being quarantined, and we all have the need for social distancing, people are estimating that approximately 85% of all the customer experiences that we're going to have by the end of 2021 are going to be without real human agents, right? So what does that mean? It means that a lot of the experiences have to be online, have to be virtual. And one of the questions is, how do we improve these kind of interactions? Another thing that we're probably all very familiar with is that we all are working from home. There's the problem of self-isolation, and when you're doing this for an extended period of time, it becomes very tiring, right? Especially if you think about it, the only way that we're communicating right now is through video conferencing. This is sort of like how we interact with the world nowadays, right? And there are a lot of technological trends, showcasing where we're moving toward and what kind of capabilities we can be expecting in the next couple of years. So here are a couple of examples of technological trends. Obviously in the space of virtual reality, right? So there's a lot of work. There's a great example from Facebook Reality Labs where they're showcasing how we can enable telepresence in 3D using realistic avatars, right? So imagine that people are remote, they can still interact with each other and feel like they're in the same space. This kind of prototype will still have to wait a couple of years until this is accessible to people. And that, in this case, they need a specific studio to capture all the performances of a subject, right? Here's another great example from spatial.io. So this is something that's already available, and the idea is basically that people in an augmented reality setting have the ability to interact with each other using a 3D avatar of themselves, right? And obviously you can imagine that avatars can still look a little bit better so that you can enhance interaction, but that's sort of like a great example of where things are moving. And when we talk about how humans have to, not interacting with other humans, but humans would be interacting with machines, obviously the use of virtual assistant is very interesting, right? So right now, most of the interactions that we have with machines are text-based or voice-based. If you think about Siri and Alexa, if you think about chatbots, the more natural way is that we have the ability to interact with another human, right? And here another really interesting example. Musicians are, for example, here's an example from the rapper Travis Scott, who's actually throwing a virtual live concert inside of Fortnite, really showcasing how these kind of virtual platforms are being leveraged to reach out to a much bigger audience, right? And that's something that I think in a in the kind of world that we're living in today is very, very interesting. So one of the things that we're also experiencing is the use of instead of having real celebrities, you have virtual influencers, right? So they are also emerging on social media platforms. Lil Miquela is a great example. They have millions of followers. They are brand ambassadors for many fashion companies, and so we're kind of like seeing a lot of these examples with how do we use virtual humans to sort of enhance our interactions between us, how we consume media, and how do we interact with computers, right? And virtual humans really are at the center of everything. And there are two problems here, right? So the first problem is how do we create very realistic virtual humans? And the second thing is how do we make them accessible? How do we build them much faster? So the standard technique of creating virtual humans is one that is very expensive, and we know this from the visual effects industry. So for decades, the visual effects industry has been using virtual humans or digital actors for storytelling, but the production of these, very, very realistic digital humans is very expensive, right? So it would cost millions of dollars to be able to produce a accurate representation of a person using computer graphics. There has been a lot of advances in the space of real-time graphics. So we know a lot of these real-time technologies from video games, and a lot of these technological capabilities are advancing very quickly. Here's a great example from Digital Domain. So where you have an actor that is performing in real time. So all its performance being captured using a motion capture suit, using a helmet camera, and all its bodies is translated onto this digital actor, right? So one thing that is still very complex here is the creation of this digital actor, right? So it still takes months to be able to create this asset, to properly process it, and you still require a large team to generate this asset. But once you have it, you can actually perform it in real time, and the results are not that bad. And in my previous job as a professor at USC, we have been working very closely with Hollywood. So here's a couple of examples of actors as celebrities that we have scanned in order to generate these assets. So those are actually used in production, but very often they require a high-end capture device. So this is an example of our Lightstage X technology. So it's basically what we call a multi-view photometric stereo capture system, originally developed by Dr. Paul de Berek. And the idea is that you have all these different lighting conditions that are controllable, and you have cameras that can actually digitize, multiple cameras that can digitize, the person in 3D. So you have a high resolution scan of the actor, and you're also capturing, complex pore details, and have the ability to simulate, the whole appearance and the reflectance of the skin inside a virtual environment. So the whole time we've been thinking about how do we use AI to make these kind of acquisitions accessible to everyone, right? So not everyone can afford this $1 million device at home. And, the future is really how can people just generate a photoreal avatar of themselves, for example, just using a cell phone, right? And that's one of the things that we have been working at my startup, Pinscreen, right? So we've been focusing on how do we use AI to basically take a single input photo and have the ability to generate a realistic digital human. So that's something you can actually just download from the App Store, and you can actually just play with it. Now, one of the challenges of when you're just dealing with a single input photo is that the lighting can be very bad. You're never in a studio lighting. You might be smiling. Your head pose might not be ideal, or you might be you just want to create an avatar of a photo that you download from the internet, and they're rarely in a ideal studio capture environment. So one of the technologies that we've recently developed, we call it deep face normalization. And the idea here is that given an input photo, we have the ability to neutralize that photo, right? So you can see that guy on the left, he's making this face, and obviously an avatar that has been generated from that picture will also carry over the lighting conditions and his facial expression. So what our normalization technology can do is that it can synthesize a new photo of him as if he was doing a neutral face. So it's trying to predict that using AI. And what we're also doing is we're also normalizing the lighting condition, right? So let me show you a couple of examples. We actually have broken down this problem into multiple subproblems. So the first one is we're doing perspective on distortion, right? So if the person has been shot with a random camera, we don't know what the focal length is, it has the ability to actually neutralize the focal length, right? And the next one is lighting normalization. So if you're taking a picture in a random environment, you might have a very strong contrasty light that is shining onto your face, and you're trying to remove that from the face. So we have the ability to neutralize it. The way it works is that we have a lot of input data where we have the proper lighting condition and one that has a non-neutral lighting condition. And what we try is we train a mapping that allows us to regenerate one that is neutral. And we can do this for the pose as well as for facial expressions. So here you have an example of this subject here who is smiling in the beginning, and we have the ability to actually neutralize the face, right? So you can imagine how this could be very useful for photo editing applications. So when we talk about these kind of techniques, very often they use something called Gans, right? And Gans stands for Generative Adversarial Network, and it's a very, very powerful technique that allows us to generate a new image from basically random noise. So we have the ability to train a deep neural network using real data and generate new faces, or we can condition it on to specific controls that we're providing, allowing us to generate the output that we want. So here's a great example of evolutions of Gans, right? So they were initially developed by Ian Goodfellow in 2014. And, it was the first time that we saw that we can generate a face that's photoreal. This is the big difference with traditional computer graphics, where people are developing, 3D techniques to represent 3D faces. You have 3D models, you have textures, you have different rendering techniques. And the idea of using machine learning here is that everything is just data driven. There is a deep neural network that implicitly learns how the generation of a face should look like, right? You basically provide a lot of input photos of real people. And then very quickly, you can see that every year there has been some improvements on, how this kind of approach is advancing. And, nowadays we can basically take from noise, we can generate a realistic new face of a person, right? And we can interpolate between them, generate faces of new people that have, never been, that don't even exist, right? And you can see how realistic these faces look like. And we actually took a very similar approach to not only generate new subjects, but have the ability to take a picture of a person produce a 3D representation of it, and also generate new facial expressions of the person. So let me show you what we call PaGAN, the technology that we developed at Pinscreen. PaGAN stands for Photoreal Avatar Gan, right? So, and it's specifically designed to generate avatars. And on the upper right, you can actually see these are basically photographs of people where, you know, we just have the frontal image. And on the left, we have one of our engineers who is basically performing facial expressions. And what we do is we analyze his facial expression, his head pose, and then regenerate a new face from the pictures that you can see on the upper right, right? And you can see that, you know, on the lower left, lower right, you basically have new expressions of people from the pictures that we have on the upper right, and, you know, generating these expressions. And, you know, we've never seen any of these expressions before. So now this approach can also be used for malicious purposes, right? So there's, I'm pretty sure many of you have heard of deepfakes, right? So there's some similarity in deepfakes in that they are new expressions that are being generated conditioned on a performer, right? And here's an example of a deepfake, high fidelity deepfake that we've generated with Pinscreen, and it's a comedy that we've done with collaborated with an impersonator of the president called John DiDomenico. Let me play that.
Hello, everyone. It's me, President Trump, the greatest president in the history of presidents. There's some disturbing things on the internet. And I know the internet. No one knows the internet like I know the internet because I'm smart. I'm really, really smart. I know technology and I have a really big brain. And my big brain is telling me there are some fake videos out there. They call them deep fakes. And there's this company, Pinscreen, and they've got like this genius guy running it. He's not as much of a genius as I am, but he's very smart with this technology. So if you see me in a video and I'm not saying how incredibly smart I am and how big my brain is and how I have the greatest memory in the history of memories and how I aced my cognitive test, it's probably not me. So don't trust it. Don't trust the deep fakes and Pinscreen. We are going to do an investigation and we're going to shut them down.
All right, so now you get the idea. And what we've been doing here is basically take an original footage of the comedian and basically synthesize Trump's face based on his facial expression, and then basically composited Trump's face onto the comedian. So this is how we do this realistic face replacement. And, you know, similar solution, you know, which is labeled as deepfakes, and there are many variants of it, is also circulating the internet. And, you know, one of the things that has to be mentioned here is that they are being used for a lot of harmful purposes, right? So as a matter of fact, 96% of all the deepfake videos that are circulating on the internet are related to non-consensual pornography, unfortunately. And that's one of the things that also makes us very worried, because you know, what if these kind of technologies falls in the hands of the wrong people and are being, you know, weaponized for the wrong purpose, right? And in some ways, what we're trying to do with Pinscreen is, you know, we're entirely focused on how do we generate photorealistic avatars, and, you know, on applications that have nothing to do with being misused. But these kind of capabilities could be very dangerous, and there's already harm that has been done using that. So it's important for us to raise awareness of this issue, and also we're actively working with government agencies on how do we fight, how do we detect these kind of deepfakes, right? So here's an example of a work that we've done in collaboration with the World Economic Forum. So this is a demo that we've shown at Davos this year, 2020, where we're basically showcasing how the technology for deepfakes how fast they are advancing. and showcase the version that is real time, right? And that's potentially very dangerous because you can have a Zoom meeting with someone and pretend to be someone complete, somebody else. And the other thing that is also very concerning is, what if the quality of these deepfakes becomes so good that people can't tell the difference anymore if they're real or not? And we have shown examples where they're incredibly real, and most of the existing deepfake detectors can't even tell from a single frame that they are fakes. So let me show you an example here. So you can see on the right is the actor, and on the left we have an example of Jair Bolsonaro.
Dirijo-me a todos os cidadãos brasileiros para dizer que nunca houve injustiça tão grande quanto a prisão do presidente Lula. Que crime esse homem daí cometeu? Ele não tem triplex na praia. Ele não tem sítio, coisa nenhuma.
Right? So that gives you an idea how far we can actually go with the resolution. And this video really shows how high res we can go. And now there's also other things that are not necessarily face replacement deepfakes, but other AI-driven manipulation techniques that are out there. FaceApp is an interesting app that allows you to age a certain person, change the hairstyle of a person, and you can see that the results look incredibly real, right? And I won't be surprised if very soon we're going to have similar capabilities in videos, right? And you can easily manipulate any content that you're generating. So in some ways we can think about how difficult it's going to be to trust a video that we're looking at, because you can potentially generate anything you want, right? And we're really at that stage where you are starting to get all kinds of capabilities, all kinds of authoring capabilities. Here's another work that we've done very recently. This one is about facial hair, right? So we've shown a couple of examples of how do we manipulate facial expressions, but you can also use Gans, for example, to author a facial hair on someone, right? So obviously for a lot of beauty apps or for hairstylists, this can be very useful, or it can even be useful for applications in crime, right? So when you're trying to find a suspect, but here you can see how you can actually have a tool that allows you to author with very fine-grained details how someone would look like. So, and it's not just for 2D editing or changing images or videos. We can also generate very, very realistic 3D content as well, right? So using these GANs, what you can see, this is a recent result that we've produced that you can see on the right. We can, from that single image, generate very realistic 3D representations of the subject just from that single image, right? So it has learned from a lot of real 3D scans how this person will look like. It doesn't have to be that specific person. It can be another person. And what you see with a traditional approach, this is one of the avatar SDKs that we had previously from 2018. You can see how the digitization technique is improving over time. Now you can see the advantage of using these AI-driven digitization methods. What I'm going to show you next is something new that we're working at Pinscreen, which is a hybrid approach. We call it hybrid avatars. And what it means is that we're trying to combine the best of both worlds when we use standard computer graphics and when we use AI-driven synthesis methods, right? Traditional computer graphics, you have full control over the avatar. And with a synthesized approach, we have the ability to generate very realistic faces. And the problem with traditional computer graphics is that it's very difficult to generate something that looks very real, especially for faces. And for the AI synthesis method, it's traditionally very difficult to control the content that is being generated. And we basically combine both of them. So why do we need that? Well, we want to create very realistic virtual humans so that we can use them to interact in the future. So let me show you how that looks like. So on the left, you have, there's a collaboration with Mike Seymour. On the left, you can see a CG version of him. And on the right, you can see a photoreal face that is generated using our PaGAN technology, which is now integrated
this
into
is Digital Mick,
Unreal
kind of a
4.
successor to Meet Mike. This is me driving this digital character in UE4 thanks to a persona rig from 3Lateral that's reading my expressions, feeding into a 3Lateral facial rig inside UE4. I also have on an XN suit to get my body motion. Now this is great, we love it, but as much fun as I am sitting here at the Modus Lab in Sydney, I can take this to the next level thanks to our friends at Pinscreen. This is Digital Michael. Now Michael is being fully driven by Digital Mick. So just to be clear about this, Mike Seymour is driving Digital Mick and Mick is driving Michael. And Michael lifts the level of realism enormously. It's doing that because it's a generative adversarial network, a GAN. In fact, it's the PaGAN 2 technology from Pinscreen. And this is enabling me to produce this incredibly realistic, lifelike version of me and control it. I think it's extraordinary technology and it's really going to be a game changer. I hope you agree.
All right, and obviously we can, integrate that into the creation of, full body avatars, as you can see over here. So you can imagine how we can basically replace real physical shootings with a virtual rendering, right? So this is something that is going to change virtual production because now we can generate very, very realistic virtual humans, at a fraction of the cost of traditional computer graphics pipelines. Here are a couple of additional examples that use this technology to create high quality virtual fashion models, right? And obviously they can move as well and can also be rendered in real time, right? So the full simulation of the virtual human is being generated. So these are examples from what we're doing here at Pinscreen. And ultimately, we're not just in the business of creating realistic virtual humans, but we're also building an end-to-end technology for virtual assistant. So let me show you the full stack AI NLP technology that we're developing. The idea is that we're sort of building this human-like Siri or Alexa interface that allows you to interact with a artificial intelligence. And the idea is that you can actually interact with this AI agent using natural voice. So we have the full pipeline where you provide an input as either text or as voice. There's voice recognition. There's a highly sophisticated AI-driven chatbot that uses, a generative language model, and then we produce voice out of it. So we're synthesizing the voice, and from the voice we can synthesize lip and expressions as well as gestures from the avatar, right? And that leads to basically our cloud-based Pinscreen virtual assistant. So let me show you a demo of how it works. All right, so what we have over here, this is our Pinscreen virtual assistant technology. It's an end-to-end system that allows me to actually interact with a virtual avatar. She's entirely rendered on the cloud and streamed in real time onto my web browser. And we're using the Unreal game engine combined with our PaGAN face synthesis technology. So this is a freestyle conversational AI demo. So all I need to do is basically press the start recording button and I can start interacting with her. Let me do that. Hi, how are you? It's good to see you.
I'm doing great, just hanging out watching some TV and eating dinner. What about you?
Oh, I just came back from work and I might need to go shopping later.
That sounds nice. What do you do for fun? What is your favorite thing to do? I've never been shopping.
Oh, that's really interesting. Yeah, I like to cook and I like to walk my dogs.
I don't have a dog, but I like animals too. What are your dog's names?
One of my dog is called Bagel and she's a toy poodle.
That's not a bad name. Do you like to play sports? I like sports.
Yeah, I used to play tennis, but not right these days. I'm not doing so much sports anymore.
What are you writing about? I love reading. I'd be interested in what you did for a living.
Oh, I'm an engineer, and I'm building technologies around avatars.
Oh, that sounds interesting. I bet you make a lot of money. What types of technology do you build?
uh, Building technologies around artificial intelligence. As a matter of fact, you are one of our creations.
That's interesting. You seem like you are very interesting. What else do you enjoy doing?
Um, what else do I like to do? Well, I love to watch Netflix shows. Do you like Netflix?
I do like Netflix as well. I love shows about crime and mystery and crime movies.
Wow. Anything that you have been watching lately?
Yeah, I guess so. But it was nice talking to you. I like you. Have a great day.
So now you've seen how we can make the creation of virtual avatars accessible to consumers, and also how can we build a virtual avatar with integrated intelligence so that we can actually interact naturally with the machine. And those are interesting technologies that could make our life and communication more natural in the future, especially when physical distancing has to be enforced. Um, so I want to show you another technology which we called volumetric teleportation. So the idea here is not to build an avatar and control the avatar, but the idea here is to have a end-to-end system that allows us to capture a person as it sees, and have the ability to reproduce this person in 3D, the entire person. So when you think about it, there has been a lot of technologies around to basically digitize a person, right? So normally, if you want to capture a person, you would use a 3D capture system. So here's a demo of a prototype from Microsoft called Holoportation. So in this system, the idea is that what if we want people to have the ability to communicate with each other? They would basically wear these AR devices so that they can see each other in 3D. But then in order to digitize themselves, they need a lot of cameras. You can see all these different cameras that are surrounding the subject in this room. And they're basically scanning the person in real time, right? Here's another example from a company called Evercoast. And they're basically using a lot of real-time depth sensors that are placed around the person to capture its performance. So this is really cool because you don't have the need to build the avatar. This could be used basically for a 3D version of Zoom where people can actually see each other. The only problem here is that you need a lot of cameras around the person, and you can only capture the person inside this studio-like setting. And again, this is not a technology that is I can imagine people having in their homes. It's unlikely that people in their homes are going to have the studio capture just for the sake of talking to someone. But if you think about, if you watch Star Wars, been always wondering how they actually do this holograms. If they had a camera somewhere, or if they have one camera, how can it see the back of the person? So we've been actually thinking about if that's something that's possible. So we started doing research on that a couple of years ago, and we started working on the problem of how do we generate a complete 3D human if you only have one view of that person, right? And we call it single view digitization. So here's a picture of me in Sydney with my friend Mike Seymour. And the first step is we first want to focus on me. So we basically segment myself against the background. So that's something that can be automated using something called segmentation network. And one thing that we've shown that it is possible to actually generate a complete textured 3D model of myself from that single image, including the back of the person, right? If we train with a lot of data, a lot of 3D models, it has the ability to, a deep neural network has the ability to use 3D deep learning to imagine how the 3D shape would look like and how the texture of the back could even look like. And one of the, and there has been some work in the past on doing this, but people could never achieve the resolution that we're seeing here. And one of the methods that we're using is called, we call it PIFU, which stands for Pixelline Implicit Function. The main idea is that we would use a voxel, instead of using a voxel grid to predict if there's something or not in space, given an input image, we basically would train a deep neural network to infer an implicit surface, basically saying that at that specific distance, is there something in it or not, right? And this allows us to not be limited by voxel grids, which are well known to take a lot of memory, right? The second problem is, most of these deep generative models, they're based on, given an input image, encode a high dimensional feature vector and then trying to decode that into a content. But then the problem is that if you have a global feature vector, then you basically lose a lot of the localized spatial information. So one thing that we're doing here is we're trying to align the input and the internal representation of that latent space with the input image so that we have the ability to preserve the details of the subject, right? So here we call it pixel alignment. So we're basically using a fully convolutional image representation to map the input image to not a single global feature vector, but basically an array that contains multiple feature vectors that has the whole context. Each of them have the context of the whole image as part of it. So here are a couple of examples of results that we can generate. So you can see that based on a single input image, we have the ability to generate a 3D model that's very plausible. And it can even handle some of the prompts of the subject, which is very interesting. Here's another example. Now, the problem is that if you just have that, then you may not have the ability to animate the content because it's just a static frame. So whatever you generate is that person in that specific pose. So in collaboration with Facebook Reality Labs, we've also worked on something where instead of digitizing the person in that specific pose, we're digitizing the person in a canonical pose so that we can actually use a body prior to reanimate it, meaning that just from that single input image, we could generate an animatable 3D model. So here's an example from this input of that woman who is like, having one hand on the waist and the other one on the belly. We can digitize the person, in the same pose, but also we have its canonical A pose and can generate this fully animatable character. The other advantage of using a body prior in order to, digitize the person is that if we were to digitize frame by frame, we can even ensure temporal coherence because we're using more information about the person. So if we were to just digitize a video frame by frame, you can see that there is some temporal inconsistency and flickering, which you can see on the right. And in the middle, you can actually see this really clean subject body motion. So one of my students also collaborated with Facebook on a work where we have the ability to generate high-res, basically process high-res input videos or images, and also get consistent output, what we call PIFU HD, right? And in this video, you can really see how we can generate high-quality subjects from just a single video. Now, for each of these examples, it still takes roughly a minute to actually generate one frame. So it takes some time to actually process the video. And for an actual teleportation system, it has to be in real time. So one thing that we have demonstrated and published recently is what we call Monoport. And Monoport is a technology that allows us to use a single webcam and digitize the performance, the whole body of the person in real time, right? And you can see, so here, the subject, my other student who is here, he's taking off his clothes and is capable of producing a 3D scan of his body, including the back, right? So let me actually show you how that looks like. So you can see now the output is rotating. That's what you see in the middle. I'll play that again. And it basically generates his body motion. And that content can also be streamed in real time into an AR device. So I can actually see the full 3D body of that person and his performance in real time on this AR device, right? It's basically a tablet where I can move around and I can actually see this full performance in 3D. Now, these are all, prototypes, but I think they are really important building blocks for, technologies that we've seen in a lot of sci-fi movies, right? So if you remember in Blade Runner 2049, you basically have this virtual avatar Joy. But then the question is, how could the person basically, how could we digitize them? How can we, recreate them in 3D? So I think one of the only missing technology here is the holographic display technology. But, the examples I was showing on realistic virtual humans, realistic renderings and representations, these are basically key building blocks toward a future where we have the ability to interact naturally with computers, right? And this, I believe, is the way we're going to interact in the future with machines. And we're very likely to interact more with machines than with other real humans, which in some ways it's already happening with cell phones. All right, with that, I would like to take questions, and thank you very much for listening.